Okay, chapter 6 is about similarity, and chapter 6.1 is ratios, proportions, and geometric means. Some of the stuff in this section is review, but it's not the same as what you've learned before, so you do want to make sure that you review and pay attention. First thing we need to talk about is what is a ratio. It compares two numbers. It's similar to a fraction, but it is a little bit different. Something you do need to know is it has to have the same units before simplifying. Sometimes you can have something like 2 inches to 5 feet. Something like that, you have to convert it. If it says something like this, 2 inches to 5 feet, we can't reduce that until we have the same unit. So keep that in mind anytime you're reducing. It can be written 3 ways. With a little colon between it, a number, a colon, and another number. It can be written to look like a fraction, or it can have the word TO in between the two numbers. All 3 of those are proper ways to write a ratio. I want to look at some examples from guided practice in the book. So this section's asking you to simplify the ratio. 24 yards to 3 yards. So because they're the same unit, I can very easily simplify that. And looking at my notes, I took 24 yards over 3 yards and treated it kind of like a fraction, but again, I can only reduce it because I have the same units. So of course I divided by 3 on top and on bottom, and I got 8 to 1. This is not interpreted into an 8 because it's not a fraction. Remember, a ratio compares two numbers. So this has to stay 8 to 1. And again, you could write it either of these formats. All 3 would be correct. Number 2, 150 centimeters to 6 meters. Again, it should jump out at you that there's 2 different units here. So what I did was convert first. So my original is 150 to 6 meters, 150 centimeters to 6 meters. I converted my meters into centimeters. And I want you to notice how I did this. So for every 1 meter, that is 100 centimeters. So this second ratio is my conversion factor. First one is what I'm given. This is a conversion factor. So remember, when you multiply fractions, which kind of what these are, I did 150 times 1 and I got 150. 6 times 100 gives me 600. And I converted everything into centimeters. Remember, that's how I did this a minute ago. So I have 150 centimeters to 600 centimeters, same unit, which means I can divide. So 150 divided by 150 gives me 1. 600 divided by 150 gives me 4. So this converted into centimeters and simplified is 1 to 4. I want to look back to guided practice. These are different kinds of problems. We're going to look at both of these. The first one says the perimeter of a room is 48 feet and the ratio of its length to width is 7 to 5. Find the length and width of the room. These are very similar kinds of problems that you have to understand how to set up. So you're given the perimeter, and all we know is the ratio of the length to the width. We don't know anything else about it. So let's look at how we set it up. The perimeter is 48 feet. The ratio of the length to the width is 7 to 5. So that means the length has a ratio of 7, the width is 5. So the first thing I'm going to do is set up my variables. The length is 7x, the width is 5x. That x represents what we're going to multiply by to make them have a relationship, basically. So the next thing I'm going to do is look at my perimeter formula. This should look very familiar to you. Perimeter equals 2 times the length plus 2 times the width. Well, if you look above, we have the length and the width already spelled out for us. So the next thing I'm going to do is simplify, or substitute, I should say. We know that the perimeter is 48. The length from above is 7x. The width from above is 5x. So now that we have an equation with only one variable, now I can simplify and solve it. So simplifying, I multiplied. I combine like terms. Then when I divide both sides by 24, I find that x is 2. But I'm not done, because remember what the direction said, find the length and the width. This is where in algebra you are taught how to define your variables. That's where this step is really important. So now I'm going to substitute that 2, which I know it is x, into my length and my width. So 7 times 2, the length is 14 feet. 5 times 2, the width is 10 feet, and that's what we were asked to find. This is kind of a similar setup for a lot of these kinds of problems. Let's look back at number 4, similar kind of problem. It says a triangle's angle measures are in the extended ratio of 1 to 3 to 5. Find the measures of the angles. Well, we know the angles of a triangle must add up to 180. So you have to keep that in mind. And this 1 to 3 to 5 is the ratio of those angles. So again, we're going to start off by setting up our variables. We have 3 angles in the triangle. One angle is 1x, second angle is 3x, and the third angle is 5x. This is where our extended ratio came from, 1 to 3 to 5. So I know that that's the relationship of the 3. The x is what I don't know, so that I can figure out what those angles are. So I know that these 3 angles added together must equal 180. That's where this equation came from. So the first angle plus the second angle plus the third angle equals 180. And then this should be fairly simple to solve. We're going to combine like terms, divide by 9. I found x is 20. But remember, it asks us to find the measure of the angles. So I'm going to take this measurement, or this x, and plug it into all 3 of these expressions. Again, this step is really important for these kinds of problems. When I plug it back in, angle 1 is 20. Angle 2 is 3 times 20, which is 60. And angle 3 is 5 times 20, which is 180. And I want you to notice 100 plus 60 plus 20 gives me that 180 degrees, which it has to be for a triangle. Solving proportions is a quick review for you. When you solve a proportion, you use cross products and then you follow your equation solving rules. The biggest thing that you need to be careful of is the distributive property. So the first problem is number 6 that we're going to do. And if you look at how it's set up, that is a proportion. It's comparing 2 numbers. When I solve this, I'm going to do cross products. So one cross product is 1 times 3x. The other cross product is x minus 3 times 4. But if you understand what I just said, when you're multiplying, that is a distributive problem. And that's probably the biggest mistake you guys are going to make. You're going to do 4 times x and forget to do 4 times negative 3. So be careful with that. When you simplify this, distributive property, multiply, move your variable to one side, divide by negative 1, x is 12. And these problems, we're just asking you to solve the proportion, so x equals 12 is enough. The next one looks like this, y minus 3 over 7, and this is number 7 for guided practice, and y over 14. Again, cross products. 7 times y is one cross product. The other one is y minus 3 times 14. Again, that is a distributive property kind of problem. Distribute on the left, multiply on the right, move your variables to one side and the plain number to the other, divide by 7 and y is 6. Again, this should be reviewed. This isn't much different than what you've done before. Geometric mean is new to you. So what a geometric mean is, I want to show you in the book the way it's explained. It's a little bit more complicated, and I'll simplify it for you. It says the geometric mean of 2 positive numbers a and b is the positive number x that satisfies this proportion. This is key. So you're saying what x will make that work? And if this makes sense from what I just talked about with the proportions, x times x gives you x squared, that's one cross product, and a times b is the other cross product. So to solve for x, we know to square root. So to sum all of this up, a geometric mean of 2 numbers is multiplying them and square rooting them. That's what I want you to remember. So looking at an example, a bunch of examples actually. So this is guided practice on page 359. The directions say find the geometric mean of the 2 numbers. The 2 numbers is 12 and 27. So what I was just showing you is that to find the geometric mean, which is x, you're going to multiply the 2 numbers and square root them. So I'm going to multiply 12 and 27. I get 324. And when I square root it, I get 18. It's as simple as that. So when you're asked to find the geometric mean of 2 numbers, you multiply them, then square root them. The other example is 18 and 54. To find the geometric mean, you multiply those 2 numbers. I get 972. And then when we square root them, 972 is not a perfect square. So I have to do a simplest radical form. And I've talked about this before. We're looking for the greatest number that is a perfect square that goes into 972. I found that to be 324 is a perfect square. So I broke it down into 324 and 3. 324 can be square rooted. It becomes 18 on the outside. 3 is not a perfect square, so it stays on the inside. So the geometric mean of 18 and 54 is 18 square root of 3. One more quick example, 16 and 8, geometric mean, I'm multiplying them and I get 288. 288 is not a perfect square, so I'm looking for a perfect square factor that goes into it. 144 times 2 is what I chose because 144 is a perfect square. Square root of 144 is 12, that goes on the outside. 2 is not a perfect square, it stays on the inside. So the geometric mean of 16 and 8 is 12 square root of 2. So what I want you to know for next class is to understand how to find the geometric mean, how to solve proportions, and how to simplify ratios. These are our basic ideas that are going to be used for chapter 6. The homework for chapter 6 is here. I did take 61 off of there. You don't have to do 61, but the other ones I do want you to do.